Ronaldo Electronica manufactures radios and tape players. Pretty sweet stuff there, ladies and gentlemen. Tape players are the wave of the future. Trust me. Manufacturing plant. Manufacturing plant capacity manufacture 600 at most 600 radios and 500 tape players. They cost the company $10 to make a radio, $12 to make a tape player. Company can spend $8,400 to make these products. Right now, the Electronica makes a profit of $19 on each radio, $12 on each tape player to maximize profits. How much do they make? How much should they manufacture? All right. Well, what is the objective? Making money. All right. Guys, please quit while you're ahead. All right, please. Pretty please. Yeah, you're right. Oh, bless you. I did that. Very good. All right, so there's my objective function. I get $19 per radio, $12 for tape player. I started doing this 12th hour. Remember how we had that first example where we wound up having our ordered pairs flip-flopped? What I did with 12th hour, I started doing this. I would automatically kind of put my graph in, and whatever variable I put first, I threw on the x-axis. So that way I knew that would just stay on the x. And that's good. I mean, I did it like that just so that it would kind of help me out. So, all right, now you talked about capacity. We know it's got to be a first quadrant problem because you can't make a negative amount of radios and or tape players. So it's got to be first quadrant problem. But it says that radios cannot exceed how many? And how, you know what I mean by at most? So it's going to be, the radios can be less than or equal to 600, and the tape players are less than or equal to 500. So far, so good? Okay. Then it talks about costs. It talks about how much it costs to make a tape player, how much it costs to make a radio, and how much overall capital they have to spend. So they have how much money to spend? $8,400. Can they spend $8,400? Can they spend more than $8,400? Can they spend up to $8,400? Okay, so that means it's another less than or equal to. And then we just put in our costs. $10 for the radio, $12 for the tape player. What did I say, 12? Sorry. Okay. So far, so good? Okay. Now, do I need to write down that it has to be a first quadrant problem? Are we okay knowing that it has to be? All right. People still want it. There's still a market for it. What happens if there's a song on the radio that you want to record so you can listen to it again later? You need to have a tape player. You don't understand the trials and tribulations of a 12, 13-year-old child back in the day when you didn't have this thing called the internet. You had to sit there and literally wait on the radio to play a song you like and hit record. Yeah, get off my lawn! All right, first thing I'm going to put in are my horizontal and verticals. Remember, these horizontal and verticals are both going to be moving inward, which makes that ordered pair 600, 500. Bless you. And now I go to use my do my ordered pairs. So if I'm going to do my covers and solves here, one of the first things you'll do is take care of the radios. Well, cover and solve radio gives me what, 840? Cover and solve the other one gives me 700. So I have a 700 up here, and I have an 840 here. Inward or outward? Inward. This one's also moving inward. Okay? Which means I have to find the ordered pairs here and here. But what's nice about that is that you already know that one of the lines is a vertical, so you know the x-coordinate. You know what's a horizontal, you know the y-coordinate. So all you have to worry about here is substituting in 600 for your r value. You'll get your t value. And then when you put in your t value at 500, and you'll get your radio value. Does that make sense? So in doing that, let's see if we can map this correctly. That would be 6,000, 2,400, so this would be 240. 240 for that one. Getting applause in the back, so that must be good. All right. 6,000, that would be 2,400, which is 200. 600, 200. Look at this mental math going on here. I am impressing, I'm just impressing myself. It's something. You know, it's the plaid shorts. I think I'm just gonna wear plaid shorts. You do that, man. I should wear plaid shorts with a Hawaiian shirt. You know, I thought about it, but then I realized I'm just gonna get two more. All right, so now we take our, hey, do I have to worry about putting this as one of my ordered pairs to test? No, you're just wasting time at that point. So we substitute in our values. We've got 600, 0, 600, 200, 240, 500, was it? And then 0, 500, and it went for 19R 10S? 12S, thank you. Trying to remember all these problems off the top of my head is T, that's why. You know why? We did so many small and large yesterday. So that's where I was getting those from. So as you substitute those through, I'm going to guess it was 600, 200. Bless you. I'm going to guess it was 600, 200. I'm just guessing on that one. Is that right? So, not bad. So, was I okay in assuming, just kind of by the feel, that you guys aren't all crying coming in this morning? Well, for the most part, that this really wasn't awful? All right, well, if it's just a normal amount, it's not an abnormal amount. If it was an abnormal amount, I'd be worried. But if it's just a normal amount, it's kind of okay. I'm sorry that your pet goldfish died. You can use them for bait. Bless you. Do turtles eat goldfish? I thought turtles were more of an herbivore, not an omnivore. Never saw a turtle eat a fish. That's pretty awesome. Pretty awesome. All right, well, I guess, let's see here. So let's take a look at, ladies and gentlemen, I am going to look at the problem where it says lots of linear programming. I'm going to look at Betty's problem. Yeah. Number one, but there's two number ones, so. The first number one depends on what side you're on.
Oh, I see.
I like to mess around. All right. All right, let's set up Betty's stuff. Betty has a little bit of different wording in hers, and I want to kind of throw out at you what it looks like. So Betty works a maximum of 20 hours a week programming computers and tutoring English. She receives $15 an hour for programming and $10 an hour for tutoring. She wishes to work between 3 and 8 hours a week on programming, but always wants to give more time to tutoring. To maximize the amount she earns, how many hours should she work at each job? Okay. What's the objective?
Profit.
Profit. Okay. So we want to maximize money. So we have money for programming. We have $15 for programming plus $10 for tutoring. So far, so good? Okay. Now, in this one, excuse me, in this one, we have a couple of different weird things that are happening. First of all, how many total hours a week does she have to work? 20. Can she work more than that? Can she work that? Yes. So we have up to 20 hours a week to work. Now, it does state that she wants a couple of things here. She wishes to work between 3 and 8 hours per week programming. That's a different constraint, if that makes sense. Yeah, that's one of those little, the programming things can be wedged between the certain values. Okay, does that make sense? Where you're between 3 and 8 hours of that. Now, it does say that she also wants to give more time to tutoring, which is vague, but as vague can be, it's a very easy thing to show via constraint. Okay. So it doesn't say that in this case that she wants to work 3 hours more per every hour tutoring or anything like that. All it does say is that she's doing 2 jobs, correct? So that means that the hours combined has to be less than or equal to 20. See how that works? Now think about the constraint like you were just saying, that the amount of time programming has to be less than or equal to 8, 3. Okay? And how can you guarantee, yes ma'am? I think, I know what you're saying with the between part, but the way that a lot of this stuff works is we're looking for intercepts. We should throw them equal. I think the wording, if you are correct, the wording is stating that it should be ish. But yeah, I see where you're going. But I'm going to go ahead and just throw it with those because that would be many virtuals and intercepts and all that. Yeah, that's a good pick up. Now the next one, it says she wishes always to give more time to tutoring. Yes, sir. See how that works? If you start thinking about it, tutoring has to be greater than or equal to programming. Yes, sir. Again, that's kind of like the semantics of how this stuff works. More often than not, when we're doing programming, the linear programming stuff, we're looking for the actual intercepts. So you want to give more time to something. In order to find the actual intercept, we need it to make them equal. That way it's a definite value. Okay? But you're right. The semantics of it is it should just be a greater than. Okay. That's where this is a little fuzzy. You kind of have to go with a grain of salt on that. All right? So this is a little bit different than the ones we've set up before. It's obviously still going to be a first quadrant first quadrant problem. So if we do this correctly, we might not have a bad idea. What am I going to put for my x values? You okay with that? Oh, you know what we got to do? All right, here's what happens. We plot and go with it just like you would normally. But that last one, I think we've had that before. We've had that slope of 1 and just shaded to one direction. Okay, so it's not like a crazy thing to make it work here. Plots of 20s. Have you guys noticed that when you're plotting these things, even though you're guesstimating where things go, if you say 20 is so far over, the other 20 should be about the same distance up. If it was half of it, you kind of cut it down. Have you started to figure that out? There was one problem on yesterday's, I think it was the third one, that if you didn't space it correctly, you wouldn't have seen the diagonal going through the box part, I think. I think that's what you guys were coming up with, if you didn't have it drawn out nicely. And it's just, it comes with time, but if you're starting to see that, you'll start to go, oh. You're welcome. Okay. Between 3 and 8. Hey, if that's 3, what's the value for t? 17. Very good. See how nice it is to substitute sometimes? This is 8. That's going to be 12. It's in between. And then lastly, we got to put in the line for the slope of 1. Now this is actually going to be pretty easy to see where it goes through. If we're going to intercept this line here, what should the ordered pair be as I go through that line if t and p are going to wind up being equal? What should that ordered pair be? Think about it, what's going to happen. Bless you. Remember, it's going to have that slope of 1. This line here has a slope of -1. What's going to be the ordered pair where they run into each other? 10, 10. We see how that's going to work? I did it. Good. The reason why I'm trying to think about that ahead of time, that way I understand where am I going to place my next line. Okay? That way I know which side it's going to be on of that 8. Does that make sense? I lost you. Okay. Here's what we've got. We've got this line here, P and T less than or equal to 10. Or excuse me, less than or equal to 20. That line has a slope of -1. Right? This line here that I'm going to graph, T equals P, has a slope of +1. Since these are, think of this as, well in this case, this is your y equals x. If y equals x, and I'm going to substitute into here, where it's x plus y is 20, that means x and y have to be the exact same value in order to make it work. That's where I'm getting that from. What's that? Yes, that would be 3, 3. And the other one would be 8, 8. Okay? So what's happening here is I know that in order for this graph to work, to be a true statement, the ordered pair there has to be 10, 10. This one will be 8, 8. And this one will be 3, 3. Are you okay with that? Which side is that one going to be pointing? I want values of t to be greater than values of p. It's going to go up, isn't it? So it's going to be up in here. So we have these. We have a trapezoid. Yay! Okay. I wanted to show you guys how that works. There's a lot of times with these graphs, you get the first 2 lines or first couple of constraints set up just fine. And sometimes it's that third constraint that just goes all haywire, and you're not exactly quite sure on where it's going to lead. So if you take it and stop for a second and think about it in terms of, if you want to think about it in terms of x's and y's, sometimes it's a little bit easier to do that. And you substitute back in, knowing that, all right, my first line was x plus y was 20. I know that x equals y, so I just have to figure out where is it going to hit. And then you just substitute it from there. Okay? Not as bad as it looked? You're not buying it still, are you? It's what all this was is I just want you to remember. These first 2 parts are easy. I'm not stepping out a little too far on that one, right? Plotting those is pretty quick and painless. What I'm looking at here is just kind of thinking about what does that actually say. If I disregard the greater than or equal to symbol, and I disregard t and p, that means that this is y equals x. Because I graph t on the y-axis, p is on the x-axis. that tells me that for every value of x, 1, 2, 3, 4, 5, the value of y is going to be 1, 2, 3, it's the same thing. So knowing that as I'm going through the graph here, as this gets plotted through, this one, the y equals x? Yep, yep. The reason that I knew that those 2 points are all, those ordered pairs always be 1, 1, 2, 2, 3, 3, 4, 4, and so on and so on. I knew that when it hit x plus y equals 20, if these two are the same, that means they both have to be at 10. So by knowing that this first ordered pair, because it was vertical at 8, that I knew that this line would have to hit it at 10, which is 2 more spots down. I'm just looking at it as knowing that eventually my graph's going to look a little, I'm foreshadowing where it's going to go by understanding a step ahead before I'm doing the substitution portion before I do the plotting. Okay, that's what I was doing there. All right. Yes, sir.
Can you just run how you got the p-values for 317?
Sure. Yep. All right. Now, are you okay with the graph of the p-values going to be between 3 and 8? So this is vertical. That means all of these values on here are always going to be 3.
Yeah.
3 plus what is 20? It's direct substitution. I'm using direct substitution. That's kind of what you were asking me earlier. A lot of times you get vertical and horizontal. It's the easiest of all the substitution things because you don't have to do systems of equations. It's the most commonly overlooked one that we get with these things. Okay. Oh, that reminds me. Yesterday there was a question. Who was it? Was it number 2? The 50 cents. When you take the 50 cents and you add it part of the constraint to your ordered pairs, when you divide by 50 cents, you're actually doubling. Did you catch that? Or did you actually take half of it? I thought I told you that when you did that when you were in Flex. Didn't you? Can I show you that? That's what most people screw up on that one. You took half of 3,000 instead of doubling the 3,000, and that's usually what happens. If you go back to your homework from last night, the one constraint, and I forgot to bring this up when we had this out earlier.